Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss PN junction fabrication and barrier formation in PN junction. Let's begin. So PN junction, if p-type semiconductor is automatically joined to an n-type semiconductor, then PN junction is formed. That portion is p type, that portion as n type, combiningly we form PN junction. PN junction. And it is a two terminal device, therefore it is further called as junction diode. We call it as PN junction or junction diode. Diode, as it is a two terminal device. And if we classify that PN junction diode, it is either step graded or linearly graded. It is either step graded or linearly graded. So, what is step graded? So, step graded it is that type of PN junction, it is a PN junction is that in which the acceptor and donor concentrations in the semiconductor are constants up to the junction. Okay. Step graded means what type of doping we add. In step graded, the acceptor and the donor concentration in that of semiconductor is constants up to that of junction. Here is the junction. If we add that of donor, then the adding process is just constants up to junction of these donors or acceptors. Therefore, that type of system is known as step graded PN junction. Next, linearly graded. So, what is linearly graded? A linearly graded PN junction is that in which the acceptor and the donor, the acceptor and donor concentration vary almost linearly with distance from the junction. In step graded system, both acceptor or donor, as we denote it, are constant up to that of junction, but in case of linearly, acceptor and donor concentration vary almost linearly with that of distance towards that of junction. In that way, it is named as step graded or linearly graded. Now, we discuss fabrication of PN junction, how we form PN junction diode. As it is categorized as step graded or linearly graded, so first we discuss how step graded PN junctions are fabricated. A step graded PN junction is produced by alloying method. What is that alloying method? In this method, a small block of trivalent impurity like indium is placed on a wafer. That wafer is nothing but N-type germanium, and the system is heated to a high temperature for short period. Let we take the N-type germanium, indium, and the system is heated to a high temperature for short period, and that indium dissolves in germanium. Now, as it is heated, so N-type germanium, now that indium is at molten state, So indium dissolves in germanium and a portion of germanium changes n type to p type and a step graded p-n junction is formed. M type germanium in that of molten state, that portion as we say indium, and that portion we obtain p type. Therefore, p-n junction diode is formed by the process of alloying method, that is the alloying method process. Next, in case of linearly graded p-n junction, it can be produced by drawing single semiconductor crystal from a melt of silicon containing the impurity of one type at the beginning, and as the crystal is drawn, the impurity of either type is added to a controlled rate to change the semiconductor from one type to another. As it is in controlled manner, so the gradation is linearly graded p-n junction. In the same way, a p-n junction can also be produced by solid state diffusion method. In that of solid state diffusion method, these are very similar. P type impurities are diffused into n type single crystal substrate and a p-n junction is formed. Here we take n type substrate, these are the silicon oxides, then p type impurity diffused, so we obtain p type, that one is n type. So finally we obtain p-n junction diode by the method of solid state diffusion. If it is in the controlled manner, then it is said to be as linearly graded p-n junction, and the method is solid state diffusion. Here we discuss two types of method, one is alloying method, another one is solid state diffusion method. In alloying method, step graded p-n junction is fabricated, and in case of solid state diffusion, a linearly graded p-n junction is fabricated. This is the fabrication of p-n junction. Next, barrier formation in p-n junction. How barrier is formed in p-n junction? A p-n junction is formed when a p type and n type semiconductors are in electrical contact with each other. This is the p type semiconductor, here is the n type semiconductor. Combiningly we form the p-n junction, let me explain what are the mechanism under that of PN junction. So, a barrier is formed. In case of P type, the majority charge carrier are holes. These are the majority charge carriers. Some of the minority charge carrier also free electrons. In case of N-type semiconductor, the majority charge carriers are the free electrons. And the minority charge carrier are holes. Some are the holes. The free electrons near the junction in the N side will initially diffuse across the junction into the P side, where they combine with the holes. First N type diffuses to that of P sides, where they combine with the holes. The holes near the junction in P side will also diffuse across the junction into the N side, where they combine with the free electrons. Similar way, holes near that of junction in that of P side also diffuse across the junction into N side, where they combine with that of free electrons. As a result, the result is that the acceptor ions near the junction in the P side and the donor ions near the junction in the N side are left unneutralized, and two layers of negative and positive ions are produced near the junction. Look here. In case of P type semiconductor, there will be the donor ions. In N type semiconductor, there will be the acceptor ions. Here the donor ions, there are the acceptor ions. These two layers of positive and negative ions near the junction form the depletion region. Here the two layers, one layer of negative ions, one layer of positive ions, and that portion is known as depletion region. Depletion region. The depletion region is also known as space charge region or transition region. The depletion region, we call it as space charge region or transition region, because the region near the junction is depleted of mobile charges. Mobile charges, the charge which are moves, either free electrons or holes, due to the diffusion across that of junction. Here diffusion occurred. Once the PN junction is formed, the depletion region created. Till now the PN junction is formed, then the depletion region created, the diffusion of free electrons and holes near the junction stop. Hence, the depletion region acts as barrier to the diffusion of free electrons and holes across the junction. Therefore, that depletion region, after that diffusion stops, it behave like the barrier. As a result, the positive and negative ions near the junction generate an electric field called barrier field. That is positive, here is negative. So, electric field is created from that negative to positive. And the barrier field is directed from N side to P side. The barrier field opposes the direction of free electrons and holes across that of junction, and the potential difference across the depletion region is known as barrier potential. The field is created, that is the barrier field. And the potential is formulated, it is the barrier potential. We can explain all such mechanism by taking the graph. We plot a graph. Origin, the donor concentration, here is the acceptor concentration, again if I plot against that of potential, barrier potential, that be the distance as the depletion region, that is the PN junction X, depletion region X1 and X2. First, on that of donor section, is the positive space charge, that is the positive space charge, that portion is the negative space charge. The variation of potential x1 potential minimum, gradually potential increases and then constant the variation of potential. Okay. That figure indicates the formation of depletion region. In that particular graph, we show the spacers in depletion resistance, and here the variation of electrostatic potential across that of PN junction. All total barrier formation in PN junction can easily understood by taking that figure. So, here with the help of this video lecture we understand the concept of PN junction, fabrication. Two method of fabrication, one is alloying method, another one is solid state diffusion. In alloying method, step graded PN junction is fabricated, and by using solid state diffusion a linearly graded PN junction is fabricated. Then barrier formation in PN junction, how barrier is formed in case of PN junction, and the idea of barrier potential. All total mechanism of barrier formation in PN junction we can easily understood by taking that graph. So, with this useful and informative notes, let me wind up this session. Thank you.